In the beginning was the internet. Okay, the ARPANET. And it was good. And many protocols sprang forth. FTP, Gopher, Finger. But one protocol exceeded them all. HTTP. And HTTP grew and waxed strong, and Mosaic came forth. And Mosaic begat Netscape, the navigator, and it was good. But there was one among them named MCI who pondered within themselves, well, this is fun and all, but how do we make money? For all requests are alike and cannot be separated one from another, and you try building a shopping flow using only a single page. So a young engineer stepped forth, named Lou, and Lou conceived of the cookie. And with the cookie was born the session. And with the session came those who desired the session of another. And that was a problem. Okay, everyone, welcome to We Fight for the Users session. My name is Mark Hoops. I am an application pen tester by trade, and I run a little company called Merostem InfoSec if anyone needs pen testing. So first off, I would like to thank everyone for joining me in their post-lunch coma. I'll try not to speak too loudly, no sudden movements. Wait, no, that's the wrong approach. I will try to dazzle you with historical vignettes and tales of the latest attack patterns to keep you fully engaged. But the question kind of remains, why talk about session defenses? Why talk about cookies and things like that? Because frankly, those are entry-level application security questions. A lot of you probably know a lot of these things. And the answer is somewhat selfish. I'm really tired of writing cookie attribute findings. It seems like every test I go through, developers or the application designers have found some reason not to do these things. And so my real goal is to arm you, who know you should do it, with the right stories to convince your Scrum Master, your tech lead, whomever, that this is worth the whole hour of dev time it's going to take to implement. Now, I have a second reason, and this was kind of fun for me. Actually, yesterday morning, I was in Telegram. There's a few channels I follow just out of general InfoSec interest. And one of them popped up this message that said, hey, I don't even remember what it's called. Anyway, this forum got shut down. Here's a new link to their support channel. And so I go to it and I realize that this is a black market site. So this is the support channel for somewhere where someone would go to buy something like cookies. And so the very first conversation I see in this new support channel was a guy coming on. He says, for those of you who don't read Russian or maybe don't read English, first thing is, hey, what do you want to sell? And this other guy responds, well, cookies and logs, presumably logins, credentials. And you said this was a cookie market. And so there's a little bit of chatter back and forth. Well, you don't sell it here. This is just a support channel. You want to go to our main market. And the guy's like, cool, how do I do that? Presumably an invite was sent in the back, and the person running this says, hey, go ahead and start selling. So this is probably the first time this has happened to me. There is a genuine market for cookies and, logins, obviously, but just the simple cookie can be resold for money on the dark web. Okay, so I promised to dazzle you with historical vignettes. I think a lot of these stories that are going to be useful in convincing other people that you really should implement these defenses are going to be historic in nature because these defenses have been around quite a while. So let's start with the original definition. This is from the HTTP RFC 1945, and this is the introductory paragraph. And there's a fun sentence here at the end. It says, referring to HTTP, it is a generic, stateless, object-oriented protocol which can be used for many tasks, such as name servers and distributed object management systems. Anybody ever written a name server in HTTP? Might be a fun challenge. But the thing I really want to point out here is this idea of stateless. When HTTP was designed, the whole goal was that the server received a request and it didn't have to care what came before, what came after. All the information it needed to respond was in that one request. So that's what it meant by stateless. And as we've already discovered, that's great for performance, but it's really hard to build a lot of the applications that we all know and love if you can't tie a previous request, specifically a login request, to the current request. And so cookies were born. And in the RFC for cookies, this is found in Section 8, and Section 8 is specifically security considerations. And so there were three things that were brought up. Now, the first two are not what you expect, perhaps. I'll just fill this all out. The first one was talking about that the browser might accidentally send the cookie to the wrong domain. Turns out that wasn't very hard to implement. I haven't really ever seen a screw up in this case. Number two, he called cookie spoofing, but what Lou really meant was the idea that one subdomain had the authority to set a cookie for the parent domain, and that you might have malicious subdomains attacking each other. And that one hasn't really proved too common, but there was a talk at B-Sides Las Vegas this year by Liv Matan called My Terrible Roommates, where some of the cloud providers have a whole lot of subdomains. And so he was actually able to construct a successful attack by setting a cookie for AmazonAWS.com and then luring his victim over to one of the other services where that cookie was then interpreted and gave him access. So it is possible. But really what we want to focus on is number 3 on his list. And it talked about or pointed out the fact that cookies, at least by HTTP, are going to be sent over plain text. So that's a problem. We have to protect our cookies on the wire. Now, Lou wasn't stupid. He already knew how to defend it. So happens that he was working for Netscape. Some other people at Netscape were working on some crazy thing called SSL, Secure Socket Layer, or a way to encrypt our traffic. Now, I find it interesting that Lou here, just in the cookie specification, just said, you're only supposed to use secure, unspecified means. So I guess he didn't want to be a homer and call out another Netscape project immediately, but realistically, that's where everything went. The attack path is pretty obvious. If the user is sending data to the server is going to set that cookie in plain text. It's going to then be submitted on subsequent requests in plain text. If an attacker can watch that, they can read it. If you use TLS or SSL, TLS, of course, being the successor to that, then they can't read it. They get gibberish. Great, right? Problem solved, right? Right from the original RFC, as soon as SSL was actually rolled out, we should have been safe as long as people use the secure attribute on the cookie. And that works really well and is definitely recommended. But some jerk named Moxie Marlinspike came along. And so this was in 2009. It was a Black Hat presentation. And Moxie had the brilliant observation that when a user types in, let's say, CNN, right? Or when they want to go to the CNN website, they usually type in CNN enter. And the browsers at the time were trying to be very helpful, and so they would automatically populate http://www.whatever-you-typed.com, right? It would fill in all the rest of that automatically, which was very useful, very handy, but as we've already pointed out, HTTP is the insecure version of the protocol. And so even if CNN or whatever website you were going to immediately returned a 302 redirect, right? No content at all other than, hey, dummy, go to the HTTPS version of this site. That request went out in plain text. And Moxie realized that if the attacker is in the middle of that request, they can modify that response. So when it comes to the 302 response that is supposed to start or instruct the browser to start a secure connection, the attacker can just swallow that. And in fact, the attacker could go ahead and load that HTTPS site, get all the content, and then serve it back to the user, conveniently changing all of the links in that response to HTTP. And then the user's next request, they'd click on an article or whatever, and that request would go out over HTTP, and the attacker is able to strip, the attack is called SSL strip, just remove SSL from the equation. If the site designer had been very diligent and put the secure cookie attribute or the secure attribute on the cookie when it was set, the attacker can strip that out too. So this very first request, at least on the particular network, became the vulnerable point. And so in 2011, a new a response header was created called strict transport security, right? This is probably less commonly known than the secure attribute on a cookie, but really everybody knows about it, strict transport security, right? The idea is that if you ever go to that website, then as soon as the server returns this header, it sets a time, usually a year, and it informs the browser, I don't ever want to see an HTTP request from you again. Everything must be HTTPS. And so even if an attacker in the future is able to get in the middle of that first, or get in the middle of the traffic, even if there's an HTTP link to this website, if they've ever set this strict transport security header, the browser will automatically convert it to HTTPS. So that's good. That's worth doing. How many of you have ever heard of a website called hstspreload.org? Anyone? Hey, maybe I'll do some good here. Okay, so there's a problem where if the attacker is able to intercept that the first time a user ever goes to, I don't know, their own bank account, maybe it's a new browser, who knows? But if they're able to get that first request, the browser still, or the attacker still has that opportunity to manipulate the traffic. And so there actually is a way you can put your website on a list. This is maintained by Google, but is implemented by all major browsers. And this is a list of websites that basically come with HSTS preset. And so if you put your site there, even that very first request will never go out over HTTP. So good to know. But network segmentation, right? It's so hard to get man in the middle or machine in the middle position as an attacker these days. Not so much. How many of you saw this article that came out in June where some bloke in Australia was arrested for impersonating airplane Wi-Fi? So he had just set up his laptop. I think he did it both in the airport and on the airplane, and his SSID just happened to match the SSID for the in-flight Wi-Fi. People would connect. For certain websites, he would serve them a bogus login page and gather all their credentials. Right? If you can provide the network, then clearly you are the gateway and you can manipulate traffic. There's another attack. How many of you have ever run NetShark on your network and seen WPAD requests, WPAT? That stands for Windows Proxy Auto Detect. It's basically your laptop or whatever system is broadcasting it saying, would you please be my proxy? And if somebody responds, then they become the gateway and can start manipulating traffic. So it is more difficult on segmented networks. ARP spoofing is possible, but is really noisy and gets picked up by intrusion detection really quickly. But there are other ways that this can be done and is actually being done. All right, this is just a summary slide. I will offer these for download at the end of the presentation, and this is the one you probably want to refer to. The only thing we haven't talked about is that very last point. I would argue that for most sites, there's really not a need to run port 80 anymore. Browsers, the default behavior has changed, and now if you type in CNN, it's going to fill in HTTPS. So that's going to be the first thing that's tried. And I don't know. I don't see a reason why. I think your site would work. Your users would not have a worse experience if you just shut down port 80. So that's my opinion anyway. All right, so that's one of the major classes of attacks against cookies. Just reading them off the wire. And I should say session tokens, not just cookies. So let's talk about JavaScript injection. And I use the term JavaScript injection. If I had a soapbox, I would get up on it right now. Cross-site scripting to me is what we all know the attack as, but it's kind of a misnomer. And I think it actually is doing us a disservice And maybe I'm just bitter because I think in one of my first job interviews, I messed this up, confusing it with cross-site request forgery. So JavaScript injection is the better term, and this is why. Great historical story here. Cross-site scripting is a term that was coined by Microsoft. Boo, no, it wasn't Microsoft's fault. So their researchers had access to a bunch of network traffic, and they started noticing that in forums, there were popping up these broken image links, right? So people could add images in their signature or whatever, and they kept seeing all of these broken links. And then they started digging in and realized that the URL that was supposedly the source for this image was actually going off to American Express. And they're like, what, is American Express hosting images? Like, what's going on? And so they took that URL and they dropped it in their browser, and they didn't see anything obvious happen. But as they dug into the parameters of that request, they noticed that there was a fragment of JavaScript in that supposedly image source tag or source attribute. And, didn't take them too long to piece it together. American Express had what we now call a reflected JavaScript injection vulnerability or cross-site scripting vulnerability, so that when JavaScript was put in this particular parameter, it got rendered on the American Express page, and in traditional or now traditional fashion, that JavaScript read the cookie using document.cookie, which has existed since the very first version of JavaScript, and then packed it into a web request, and it got sent off to the attacker. So by using these image tags, the attackers were stealing people's American Express session tokens, assuming that they viewed that forum with an active session in place. And so because this attack started from these random forums and then went across sites to American Express in this case, that's where the term cross-site scripting came from. And it's just sort of stuck, even though these days, very few, I would argue, at least the smaller percentage of attacks of JavaScript injection attacks actually involve multiple sites. It's almost always adding content to the site that is being attacked. So defending against this, HTTP only, right? Set that attribute on the cookie, you're done. Next slide. Except, how many of you have had these conversations with your developers? Would you please set the HTTP only attribute? And they say, but Angular or React, right? My big fancy client-side user interface, I've got to have access to the cookie so that I can submit it with my API call to actually make the site work. Okay, well, that's the argument. So let's say, for example, we get this set cookie response, right? This is from our API, from example.com, and we set our HTTP only cookie. The developer is absolutely right that if I go to my console and I type document.cookie, I'm going to get undefined, right? The browser will block access to that cookie due to this attribute. That's the whole point of it. We understand that. Okay, but what if I write a new XML HTTP request, right? This is the underlying JavaScript call that pretty much all network requests are built off of. And so I'm going to submit that to example.com/API/cookie test. I should be pointing up here. Does the cookie get sent? And the answer is yes. The XML HTTP request is actually an API going back to the browser, and that request passes through the cookie logic that says, hey, do I have any cookies for this domain? And if it does, the browser will add that cookie. So I have a hard time making a blanket statement because front-end developers do all sorts of wacky things. I'm a little bitter because I can never read that code. It's always minified and a pain in the rear. But front-end developers are always doing weird things, and they're claiming that they need access to the cookie, and I'm arguing that they don't, and we'll see who wins. Don't know. All right, I briefly mentioned not all cookies or not all session tokens are cookies. Kind of along with the rise of the JavaScript front-end applications, people have sort of shifted to using authorization tokens or putting session tokens in authorization headers. And the bearer token is part of the very early specifications, right? And so this is good or it's reasonably effective. It's certainly secure against reading over the wire as long as you're using HTTPS, but JavaScript is able to read those headers, and so this becomes vulnerable. Let me back up. JavaScript, if it's going to add that header to a request, the JavaScript has to have access to it, and if your client-side JavaScript has access to it, your JavaScript injection attack has access to it, and so this is a greater risk in that perspective or that respect. But there is a technique that can be used to block this, and that's using worker threads. And what this does is your main JavaScript runs in one context or one closure, and you can spin up a separate thread that has effectively a separate memory space. Both of these are underneath the browser, but the main user interface processes cannot access the memory of this worker thread. And so if you structure things where your main thread calls the worker thread, like it calls the login request, worker thread makes that request, gets the token, does not pass it back to the main JavaScript, then that worker thread can hold on to it, add it to all future requests, but that token is protected in its own memory space, and the JavaScript injection is not going to run in that memory space, so things are better. So those are my recommendations for JavaScript injection. I mean, other than just don't be vulnerable because it causes a lot more problems than just session attacks. Okay, so let's say you've locked down your cookie from JavaScript injection. You have locked it down from network sniffing. Is all well? Not quite. What if I was able to make a request and perform an attack without actually needing the value? So if we rewind back to our setup for our cross-site request forgery, JavaScript injection, this one, it truly is cross-site, right? So cross-site request forgery, you're familiar with this, I expect. Same setup. You have, let's say, an image tag, could be another tag, that generates a request back to American Express or some other vulnerable site. You're not executing JavaScript, so that token is not going back to the attacker, but you are calling an endpoint that just happens to exist on this website. And so I've made up this example of, there we go, add editor, right? Some endpoint that's what it's going to do, and it takes a couple of parameters. What document do you want to add an editor for? Who's the user who's going to be this new editor? And as I've already discussed, if that image tag or whatever tag submits this request, the browser is going to add the cookie for the victim site automatically, and then the site is going to get a cookie. It's going to be valid. It's going to get an endpoint, which it knows how to handle. It's got all the parameters. It's going to do the thing. And user 42 is now going to be an editor of document 21 based on the token that was submitted by whatever user happened to visit this forum, right? So that's not good. How do we block that? In order to have a cross-site request forgery attack, there's 4 conditions. I'm not going to go through all of these. Some of them are kind of esoteric, like you can only CSRF a get or a post request. You can't do that for an update or delete. But the simple thing is just add a parameter that the user can't guess. We call these CSRF tokens, right? I'm going to set that one aside, assuming you're familiar with it. The same site attribute, this is worth just a minute of discussion. The same site attribute gets added to the cookie, and there are 3 values for it: none, lax, and strict. Okay, we can all pretty much see that lax is not going to be the optimal security, but what do you think? None or strict? Which is more secure? None, raise your hands. Strict, nobody's playing. Oh yeah, okay, good, good. All right, so none shuts off same site or the same site attribute, which to me seemed counterintuitive. I had to read this like 3 times before I find it stuck in my brain. But none means that anytime there is any sort of reference back to the domain, the scope for this cookie, that cookie is going to be sent along. Lax means only if the user clicks an active link and is going to that website. And then strict means only pages that are within that same origin are allowed to have this cookie added back to it. So same site equals strict is really what you want, unless you're very deliberately want requests from other websites to be treated as logged in. Now, I do need to quickly point out, if your site is vulnerable to JavaScript injection, then as far as cross-site request forgery attacks are concerned, which I guess in this case would be same-site requests, all is lost. Like, all of the defenses that are designed to block cross-site request forgery fall apart if you're executing JavaScript on that same site. So I can point out the different defenses, but just don't be vulnerable to JavaScript injection. That's the answer, right? Okay, I also feel obligated to talk about clickjacking. It's a thing. It happened in like 2009. It could happen again, but you just don't see it. People don't invest the time into making this happen. It's really easy to prevent. Originally, there was a response header X-frame options. That's actually being deprecated. It's still totally supported, still good to use. But inside the constant security policy, there's now a directive called frame ancestors, does exactly the same thing and allows you to block clickjacking. Okay, one more topic, then we'll get into the new stuff. If a session token is compromised, there are more defenses that we can put in place, basically to limit the blast radius. So typically, the lifetime of a session is from login to log out. If an attacker compromises that token, they can use it from the point of compromise until the user logs out. Okay, obvious here. But what if the user doesn't log out? We can use the token forever, right? Not quite. Just about every site implements an idle timeout, right? What sites often forget is to implement an absolute timeout. Because if, as an attacker, I get that token, it's very easy for me to set up a script that just fires off some stupid page load every 5 minutes, and it just keeps going, and the server updates that last used time, and that token just stays alive. And I often keeps tokens valid for, a week, 2 weeks, 3 weeks, however long the engagement is, just to prove that I can. And so if you don't add this absolute timeout, at some point, that token needs to die. In my opinion, that should be about a day, but it's your risk management to decide that. But there has to be some sort of absolute timeout, or that token really will live virtually forever. Hard to predict when the session cache gets cleared out. It depends on whether it's stored in memory, stored in a database, whatever. All right, this brings us to why I don't like JWTs. JWTs aren't that bad, but they're just slightly worse. And so the more that I see them being adopted, the more it just makes me unhappy. And really, it boils down to a very simple problem. We've got this login, log out scenario. Only with a JWT, it is valid until its expiration date. Nothing that the user can do, nothing that the server can do, short of changing the signing key, will invalidate that token. Not entirely true. You can tuck a session identifier inside the JWT, and then it just becomes like a regular session token that you manage and track that way. But that's not what the JWT builders intended. So to me, this makes JWTs just about 5% worse. And the other thing to point out is a lot of times JWTs are implemented as an authentication token and a refresh token. And the authentication token will only be valid for 5 minutes, 15 minutes maybe, and then you refresh with a new token. As an attacker, if I was going to be able to get the authentication token, I can usually get the refresh token. And so you really have to think about, from a security perspective, the full life cycle of the refresh token as well. Let's quickly talk about this one. Another way that we can add layers of defense to our session is by limiting the number of sessions that a user can have. If I log in from my computer, and that's good, and then I go over to my friend's computer and log in, to me, it's reasonable that that original session should be terminated. And for most applications, that makes sense. Now, email's an exception. There are definitely exceptions out there. But to me, one session is generally enough unless you specifically intend the user to have active sessions on multiple devices. Now, if you do, then it's really nice to add some way for the user to verify all of these active sessions. Give them a hope of noticing when an attacker has compromised their credentials, whether that be their login or their session token, noticing that, hey, wait a minute, I didn't log in from Virginia, right? So display the list somewhere, usually in the user menu, display the time of login, geolocate that IP. It's not perfect, but it gives you an idea, and maybe the device type, right? Is this Windows? Is this Android? Is this Mac OS? Whatever. And so that the user can identify things that are anomalous. And that works both for multiple sessions. You can also do it for a single session. You can just add the last login, and it adds a layer of defense and is recommended. Oh, one more thing here. Re-authenticating before a sensitive transaction is another great idea. If I compromise your session token and then go to add myself as a payee to your bank account, prompt me for either my password again, my two-factor authentication again, something to prove that I really am the real user and I didn't just steal a token. All right. So let's get to the interesting stuff. And I've talked way faster than I thought, so we've got plenty of time here. What are we doing now? Well, people have, very smart people who are trying to defend things, which often is coming from browser companies, which I think is interesting. They've realized that cookies really almost entirely belong on one device, right? I've labeled this cross-device cookies aren't a thing. If I log in from my laptop, I submit my credentials, I get a cookie, that cookie stays on the laptop. There's no valid use case where I copy that cookie, go over to my other desktop or my phone and use that same token there. And so these smart people have started coming up with ways to try and prove that the cookie I issued to you hasn't left the device that I issued it to. And so the first attempt at this was championed, published, right? The working groups talk about this. I'm going to attribute it to a single company because they took the lead, but it's not just Microsoft doing this. But they formalized this standard called token binding. And token binding has 4, I'm going to say, key elements. This is my summary, not theirs. But it starts out with a public-private key pair that the client generates. Okay, so when I want to log into a site, I initiate a TLS connection, and the way they chose to implement this, and I think, well, anyway, no editorials yet, you add a TLS extension flag that says, I'm going to use token binding for this request. And then the client generates a public-private key pair. And that may be done either in software, better, it's done in the TPM, right? Your trusted platform module. Hardware security module is similar. One of the differences, I think, is that the TPM actually generates the private key and stores it. The HSM just stores things. Regardless, you generate this private key pair and you store it off into hardware, into this isolated place. And the design of these, the HSM and the TPM, is that I can ask you to sign something for me, but I can never get that private key back. That's the intent anyway. And so the way this protocol works is it takes advantage of that fact where the client takes the public half of that key pair and sends it along with the login request to the server. And so if the credentials are valid, the server issues a token, and in its session store, it records that public key. And now on future requests, the client has to encrypt something or sign something and send it along with the request. And now the server can decrypt that thing, validate the contents, and now it knows that whoever sent this request had access to the TPM on that specific device. And so we have bound the session to that device. Great, brilliant. But here's where things get a little wonky. With this particular implementation with token binding, what they chose to encrypt were the constants that get exchanged in the initiation of a TLS connection. So, I mean, this is part of the Diffie-Hellman exchange, right? You go through all of this, and there are these constants, and both sides know them. They haven't been transferred across the wire, so they're secure. And so that's what they chose to encrypt to improve that this is the device we think it is. And that, in my opinion, and in what I've read online, proved to be the downfall. Because if any of you have, I don't imagine many of you have tried to code a browser, but those sections of code are very far from each other, right? Establishing your TLS connection and managing your cookies are just totally separate modules. And as security professionals, we recommend that people don't roll their own encryption. I don't want you going through the TLS connection initiation protocol because it's complicated and it's easy to screw up. And so it became very difficult to implement. And while most of the browsers did have a draft version of this, it just died when that needed to be implemented inside like Java and Python and all of these other languages. There were too many things that needed to be able to work with this type of session management, and it became difficult. And so after a few years, there was no adoption, and everybody except everybody except Edge has now pulled support for token binding out of their browser. Okay, missed that point. All right, so here's the new model. And this was put out by Google beginning of this year. So it's too early to know whether or not this is going to be picked up. Very similar. It still relies on the TPM of the device, generates a public-private key pair. But in this case, the server initiates the exchange, right? It says, I want to use a device-bound session credential. And so it returns an HTTP response header that has a challenge, and it also has some URLs that are going to be used later in the process. And so the browser dutifully generates a new public-private key pair, stores it in the TPM or HSM, and then it encrypts that challenge, and then sends that in a post message back to one of these endpoints. There's two endpoints, a start session and a refresh token or a refresh endpoint. It appears that the server is able to determine, like, to name these what they want. So then when I submit the signed credential, or the signed challenge rather, I also submit my public key. The server stores that public key, gives me a token. Now, in this case, the browser uses that token directly. This is a short-lived 5-minute token, basically like your authentication token versus your refresh token. So the browser uses that for 5 minutes, and then when that time expires, it calls out to the refresh endpoint, gets a new challenge, signs it, and gets a new token that way, right? So on the one hand, that token that is issued by the server is still technically vulnerable. I could steal that, and I could use it for all of 5 minutes. But then as soon as there is no refresh token that I can steal. And so as soon as that 5 minutes elapses, I need to have access to that TPM, or I can't successfully call the refresh endpoint. So, challenges for adoptions to device-bound session credentials. First one is that not all of our devices have a hardware security module, or the trusted platform module, right? And so Google actually at this point has implemented a software version of this, which is not going to be as secure, but is something, and it will hopefully help drive adoption. They're using a JWT. Very disappointing to me. But technically, it's not actually a security issue because that JWT is only like very short-lived, right? And so my objection that you can't ever terminate it, you can't log out, doesn't really apply. So I'll suck it up and live with it. And then, so the last big challenge is adoption, right? Google's put this out. It's been around, I think they released it in April. So that's 6 months now. As far as I know, no other browsers are supporting it yet. And what may be worse, I went looking for a server that supports it, even put out by Google so that I could try this and examine the traffic and see exactly how it works. I couldn't even find a server to test with. So it's early days, we'll say that. All right, conclusion for this whole discussion. Session attacks continue to evolve, right? Even the oldest defense measures, cookie attributes, creative people are trying to find new ways to break it. But those defenses largely are still very effective. And if you forget them, there are people out there who will take advantage of your forgetfulness and will steal the tokens for your users. They are usually trivial to implement, right? All you're doing is adding a response header, setting an attribute on a cookie. It should be an easy conversation to get into the development pipeline. but for whatever reason it isn't. Hopefully some of these stories about attacking and how the credential or how the defense actually works will help with that conversation. But truthfully, I hope that device-bound session credentials catch on, right? That total game changer. It nullifies most of the attacks that we discussed today, because getting that cookie and using it on any other device becomes impossible. And then that basically takes all the benefit out of stealing it from the attacker. So a couple of things. For a series of blog posts I wrote, I came up with this graphic. That's probably too small to really read, so I didn't use it much in the presentation, but it's kind of a fun reference point if you'd like to have some of these discussions. And the idea is it just lays out different attacks and the proposed defenses. There's always a little bit of cat and mouse, so sometimes you get an attack in the middle of a defense chain because it goes around the original defense, but it's something to look at. And that can be found, this is the slide you actually want to take a picture of. So posted all of this on the Meristem blog, along with articles that break down each of those attack chains. So if there is something that you're trying to make an argument for, hopefully I've encapsulated everything that I've said and more in those articles, and you can use those as a reference point. Again, I'm Mark. You've got my email address. You've got LinkedIn. I really don't use any other social media, so I didn't bother putting it up there. I would very much enjoy if you have any questions, if I'm wrong, if you'd like to argue with me how JWTs actually have some good use on the planet, come find me in the hall. I'll be wearing some shirt with a hexagon logo on it all week. So thank you. We do have time. Are there any questions? One here.
So with DSC, you were saying that like the temporary code that works, you can steal that, you that or multiply that, but then like you could just steal it, right? Like I got one from you and probably paid four from you, but we could do that over and over again.
Yeah. So the question here is, or the point he's making is, if I steal one of the short-lived device-bound session credentials, I could probably steal another one. And you're right. As long as the attacker has access to the victim's PC, there's frankly a lot of attacks they could do. It would technically be possible, I think, if the browser can call the TPM, I should be able to call the TTM as well. Or I should be able to call a function in the browser that will then call the TPM, right? So as long as I made access to the victim's machine, it's still a bad day. And device-bound session credentials won't really prevent that. But it will stop at least the sale of that token. It will stop the long-term use of it. Any other questions? Okay, thanks again. See you later.